Okay, in the last class we have discussed about the initialization command word of 8259, the programmable interrupt controller. So once this 8259 is initialized, then it is ready for processing the interrupts. Okay. Now the way in which the 8259 is going to handle the interrupts, so we have 3 operational command words. OCW. If you take OCW1, the operational command word 1, this is used to mask the interrupt requests. We have 8 interrupt requests, IR0 to IR7. We can mask any interrupt request or you can enable any interrupt request. Okay. Further, this command word format will be used. This is T0 is directly for M0, M1, M2, M3, M4, M5, M6, M7, and this is A0. This will be always 1 for OCW1. So this basically, this is D0, D1, D2, so on up to D7. So this M0 is correspond to IR0, M1 is correspond to IR1 and so on. So if you want to mask any particular bit here, if this bit is equal to 1, the corresponding IR is masked. Corresponding IR is masked. If this is equal to 0, the corresponding IR will be enabled. If I take an example, I want to enable IR5 and IR6. And you mask the remaining IRs. Then what is the OCW1? So IR5 is correspond to this, IR6 is correspond to this. So these 2 bits should be 0, remaining all should be 1s. 1, 0, 0, 1, then all zeros. This will be 90H. If I load 90H into operational command word register 1, then IR5 and IR6 will be enabled, whereas the remaining all will be masked. This is about the first operational command word. And the second operational command word, OCW2. This is basically used to reset the ISR bit. Also, you can use this for control of end of interrupt. End of interrupt. Is EOI. We know that this 8259 is having 3 registers. This is IRR, which is interrupt request register, where this IRs will be applied, IR0 to IR7. Then we have priority resolver. Then we have here in service register ISR. Of course, here we have this interrupt mask register also. So once a particular interrupt, say IR0 is serviced, so how to represent the end of the interrupt? Start of the interrupt will be whenever this IR0 requests, this IRR, if this is having highest priority, then the priority resolver will send the corresponding bit of ISR to 1. Then this will be requested here through INTR signal to the microprocessor. Then microprocessor will send the INTA bar signal, interrupt acknowledge signal. Then the corresponding call instruction will be executed. Now here, how to represent the end of the interrupt? So we have discussed about the start of the interrupt, how this interrupt service will be started, and how to represent the end of interrupt. This is also equally important. So in order to represent this end of interrupt, we will use OCW2. So there are three ways to represent end of interrupt. Okay. Before going for this format of OCW2, so I will discuss the ways in which end of interrupt can be performed. One is called specific, another is non-specific, another is automatic. In case of specific EOI, we are going to specify the bit which is to be reset in the ISR, as the name implies. So whenever this 8259 receives this command, the specific EOI will be sent. Specific EOI will be programmed by the OCW. Whereas in case of non-specific EOI, as the name implies, by default the interrupt which is being currently served or highest priority interrupt, which is being currently served, by default this is highest priority interrupt. So the corresponding bit of this ISR will be reset in case of non-specific EOI. So in case of specific EOI, the command specifies, here we have to use OSERW. So the command specifies as the name implies which ISR bit is to be reset. So I think now the difference between specific EOI and non-specific EOI is clear. So in case of non-specific EOI, by default the interrupt which is currently being processed or being served will be reset. In case of a specific EOI, the command specifies, we have to give through this OCW2, we have to give which bit is to be reset. There is one more EOI which is called automatic EOI. Here there is no need of command. By default in the third INTA bar circle, in third INTA bar cycle, the corresponding ISR bit will be reset. But the drawback of this automatic EOI is, so the ISR does not have any information on the interrupt which is being processed. That is the drawback of this one. So normally we will use either specific or non-specific EOI. Now coming to the format of OCW2. So the format of OCW2 will be, here we have L0, L2, L1 bits. This is L0, L1, L2. These 3 bits are going to decide the level to be acted upon. So if this is 0, 0, 0 by default, this is IR0, IR0 level will be used, 0, 0, 1, IR1 and so on up to 1, 1, 1 means IR7. Then the next bit will be by default 0, 0, we are not going to use this. And the next 3 bits is going to decide the mode. This is called R bit, rotation, it is going to decide the rotation, then SL bit, EOI bit, and this is of course A0 bit which is 1, so these are D0 to D7. Now coming for these 3 bits, we have 8 combinations and we have 8 different modes. If this is 0, 0, 1, 0, 1, 1, this is not in the proper binary order, 1, 0, 1. So there is some reason for why this is having some non-specific order. I will explain. 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 1, 0. So this side, these two will represent end of interrupt. End of interrupt. These two will specify automatic rotation. And the remaining is going to determine specific rotation. This we have already explained. The other side, the first one represents non-specific EOI command. I have explained what is meant by non-specific. And 0, 1, 1 represents specific EOI command. Then rotate on non-specific EOI command. Rotate in automatic EOI command. Rotate on automatic EOI command. Rotate in automatic EOI clear. This is set and this is clear. Both are same, but the difference is only set and clear. Rotate on specific EOI command. And set priority command, no operation. So because these two represents end of interrupt, these three will be automatic rotation, these three will be specific rotation, that is why I have given this in the random order. Okay. And this non-specific and specific automatic UOE just now I have explained. And coming for this specific rotation and automatic rotation, this we have discussed in the earlier class. So in case of specific rotation, as we know that, so in case of specific rotation, we will be having this IRs will be assigned the priority. Okay. In specific rotation, any IR can be assigned lowest priority. For example, if I assign IR 4 as lowest priority, this will be clear if I give an example how this IR will be assigned lowest priority. Then by default what happens is this IR 7, IR 6, IR 5, IR 4, IR 3, IR 2, IR 1, IR 0. So if IR 4 is lowest priority, the lowest priority will be represented by 7, 0 is highest priority. Then automatically the next one IR 5 will be having highest priority 0, 1, 2, then 3, 4, 5, 6. These are the level of the priorities in case of a specific rotation. Whereas in case of automatic rotation, by default the IR which is being currently served will be having highest priority. So in case of automatic rotation, the IR which is being currently served will be having highest priority. Similarly, the order of the priority will be, for example, this if IR 7 is currently serving, so this will be having highest priority 0, then the next highest will be, which is 1, will be assigned to this 2, 3, then 4, 5, 6, 7. This is the difference between the automatic rotation and specific rotation. There is one more rotation which is called as specially specific rotation. Okay. So in that case, so a slave, if it requests the master, so while the interrupt is being served, the slave can request for the another interrupt also. So this is basically used with cascading mode. So I will discuss that while discussing about OCW3. So this is about the OCW2. Now OCW3 will be used for only some special purposes. Operational command word 3. This will be used for only some special purposes. So in this, the format of this OCW3 will be this is PR, RS, then we have 0, 1 by default, then we have ESMM, ESMM. Then D7 is 0, This is D0, D1, D2, D3, D4, D5, D6, D7. Then by default A0 is 0. D4 is also 0 here. You see ESMM. This is simply SMM. This is 0. So these two bits will be 0, 0 means 0, 1, 1, 0, 1, 1. So 0, 0 and 0, 1 there is no action. In case of 1, 0, read IPR on RD pulse. Next RD pulse. Read IPR on next ID pulse if it is 1, 1. This is read bar pulse actually. So basically in this OCW3 the INTR is disabled. INTR will not be used. During the read bar cycle only the interrupt process will be takes place. So in normal operation the IR0, IR1 so on up to IR7, if any request comes on this one, the IR with the highest priority will be serviced through INTR. So this 8259 will send INTR to the microprocessor, then the microprocessor acknowledges through INTA bar, thereby the type of interrupt will be specified, means the type of call instruction. After that the particular interrupt will be served. Whereas in case of OCW3, in case of a special mask, this is called special mask, this INTR is not used in special mask. Process. Only read bar signal. So during the second pulse, during the third pulse, we are going to send this 10 and 11 and correspond to these two bits. This is the read specific mask, set bit mask. This can be 0, 0, 0, 1, 1, 0, 1, 1. This is the reset specific mask. Reset special mask. This is set special mask, and here there is no operation. This is about the OCW3, but the OCW3 will be rarely used in normal applications. So these are about the three operational command words of 8259. So we have discussed about the initialization command words, then operational command words. The initialization command words, as the name implies, they are used for initializing the 8259s, and operational command words is going to decide which ISR bit is to be reset and how this end of interrupt operation will be takes place. So I will take one example how this ICWs and OCWs will be formed for a given specifications, and I will end this 8259. So I am giving an example. So here I want to use 8259, I want to assign IR6 as lowest priority. Then we have special mask mode. And single level triggered, single mode and level triggered mode. These are the specifications that I want to use, and I have to program this 8259. Non-specific fully nested. then specific EOI mode, so what are these ICW1, ICW2, ICW3, ICW4, similarly OCW1, OCW2, OCW3. There are totally 7 command words, 4 initialization command words and 3 operational command words. Okay. So if I go for this operational command word 1, OCW1, suppose if I want to mask IR4, so this D0 to D1, D2, so on up to D7, this is M0, M1, M2, M3, M4, M5, M6 and M7. So I want to mask only IR4. So IR4 means this correspond to this bit will be 1, remaining all will be zeros. So the hexadecimal equivalent will be 10H. Okay. Now if I want to use a port address, say OCW port address is some 0740H, this is 0741H, this is 0742H. Then in order to load this one, so what we will do is move dx comma 0740H, then move AL comma 10H, out dx comma AL. So these are the instructions used to load this 10H onto OCW1 whose address is 16 bit. In case of 16 bit address, you have to take into DX register and then you have to specify in the out instruction DX register. So similarly we can form OCW2. If I form OCW2 here, so I want to assign lowest priority to IR6. So this L2, L1, L0 bits will be 6 means 110. So then correspond to this is non-specific EOI mode, fully nested. So the corresponding bits of this, the remaining 3 will be, this is 0, this is 1, 1, 0. And this is 1. So what will be the control word? This is E6. So the corresponding instructions for this one will be move dx comma 0741H, move AL comma E6H, then out dx comma AL. So like that we can initialize these registers. Similarly you can have the formats of this ICW1, you take the corresponding addresses and you take the format based on the specifications. We can generate the hexadecimal equivalent of that ICW1, ICW2, ICW3, ICW4, and you can load those values into corresponding registers by using similar type of instructions. Okay. So as I have told, the type of this program also has to be mentioned. So if I use this type as 128, say, so once this IR is requested, a call instruction will be executed, because interrupt process is nothing but, so whenever the microprocessor executes, so whenever an interrupt occurs, it completes the execution of the current instruction, it will go to a subroutine called interrupt service subroutine. This is called interrupt service subroutine, and this first address is called interrupt branch address. This is called interrupt branch address. So this interrupt branch address will be different for different IRs. Totally we can have 64 different IRs in a cascading mode. Okay. So this will be one of this type 0 to type 256 interrupts. We know that in case of 8086 we have 256 software interrupts. So type 0 to type 255. Each will take 4 locations. So the contents of IP will be, so in general if you have INT NN, contents of IP will be is equal to 4 into NN, and contents of CS is equal to 4 into NN plus 2. And in this actually INT 0 to 4 we have some special purpose, and INT 5 to 31 they are reserved. So only INT 32 to 255 are allocated for the user for external use. So correspond to this IR0 to IR7, even again in cascade mode IR0 can be connected to 8 more interrupts. So you have to use one of this INT 32 to INT 255. Okay. For example, if I use INT 32 type of interrupt for IR0, say IR0 I want to operate in type 32. So what are the corresponding addresses? 32 into 4 is 8, 128 is decimal, hexadecimal will be 16, 16.6 will be 96, 16.7 will be 112, so 16.8 will be 128, 0 is the remainder, 16 zeros, 8 is the remainder, so 80H. So this is correspond to type 32 means this is correspond to 80H hexadecimal value. So in 0080H here we have 00080H and 81H you have to store IP 00081H, and in 00082H 00083H you have to store CS. Then you have to jump to the corresponding address. So here this IP values will be there, here CS values will be there. So using this IP and CS values it will compute this interrupt branch address. So this is also another specification that you can give to program the 8259. Okay. So these are all the different specifications. Using these specifications you can write the programs for the 8259. So this is all about the 8259. So we will discuss the next peripheral device which is a DMA controller in the next class. Thank you.